All right, I'm going to do a couple examples here of the central limit theorem sample sum. And so I pulled these up off your report. In a Las Vegas casino, gamblers lose a mean of 11 cents on each roulette game with a standard deviation of $3.99. Since the standard deviation is quite high with respect to the mean, roulette players often win money on a bet. Suppose a gambler plays roulette for 100 bets straight. What is the probability that he will be winning after 100 bets? Hint, he is winning when the amount of his total earnings is positive. Carry the intermediate computations to at least 4 decimal places. Report your result to at least 3 decimal places. So I hope you have that one down somewhere. I maybe printed that example. I gotta move my camera here and find my piece of paper. And so, if we are finding here what the expected value is, the expected sum is the sum of the expectation that he is, got to go back up to the question here, loses 11 cents on each bet. So, we expect him to lose 11 cents on each bet. And so, losing money, we would have negative 11 cents. We're doing 100 bets. So 100 bets times negative 11 cents means we would expect him to lose $11 when we do that. Now for the variance on there, my variance is my standard deviation squared. So for my variance, my standard deviation was $3.99. So if I take $3.99 and square it, I gotta grab a calculator here. I don't have one handy. Let me use the one on the computer. 3.99 squared is 15.9201. So that was my expected value and my variance that I'm going to need for this problem here. And so, now in this case, again we have 100 attempts, so I'm going to take that variance that I just found times 100, just like I took the 11 cents times 100. So when I multiply that by 100, I am going to get 1592.01, since multiplying by 100 just moves my decimal 2 places. So in this case then, the standard deviation is the square root of that value. And so for my standard deviation, I'm going to do the square root of 1592.0. That was supposed to say 01, and I wrote 00, but it was 1 cent on the end, 0.01. And so again, if I grab my calculator here on my computer and do the square root of that number, I should have left my calculator open, but I didn't. The square root of 1592.01 is 39.9. So my standard deviation for my 100 attempts would be 39.9. So then in this case, I am going to substitute my numbers into my formula here. And I am going to do P of Z. And we're going to use greater than because we want to know if we're going to end up with winning. And if we're going to win, we're going to be greater than 0, right? So we're going to do 0 minus the expected value up here, which was the negative 11, over our standard deviation, 39.9. So in this case, since this is a greater, When we use our Alex calculator, it's the less than or equal to. You have to end up doing 1 minus then when you put that into the Alex calculator. I had to bring up the Alex calculator because I was just using the one that was on the thing, but I got to log on as a student here so I can actually access the Alex calculator and punch that problem in then. So if I enter the student view here and bring up a problem, eventually I'll get to a problem where the calculator is active. It's not the same problem, but I just need the calculator. So if I go over here to the Alex calculator, I'm going to do 1 minus, because on the Alex calculator we have P of Z is less than or equal to, but we want to know the probability when it's greater than. So I'm going to do 0 minus my negative 11, which would make it 11, but I'll just type it that way anyway. This part here is going to be a fraction over that standard deviation value, 39.9. And so when I enter that in, I end up with 0.391393. I didn't remember what to round that off to, so I've got to pop back over to what the question said here, but that's the value I got on my calculator. Rounded off a little bit, of course. There's a few more decimal places going. I didn't really even round. I only wrote down that many decimal places. But let me go back here to what the question was. Oh, let me hope it didn't close my question on me. Of course it did. Let me find that question again. I gotta get back into your stuff to see what that exact question was here. So just a second. And which one was it here? Okay, there it is. So it says that carry your intermediate computations to 4 decimal places. I wrote way longer than 4 decimal places. Round your answer to at least 3 decimal places. So when I round off my answer there to 3 decimal places, 0.391 then is going to be the probability that I am going to end up winning, because my amount has to be positive, and that's why I had to use a greater than here, because if my winning amount is positive, I'm greater than 0. If I would be losing money, then I would be less than 0. And again, because on the Alex calculator, it's a less than or equal to. If I have a greater than, I have to do 1 minus that. Let me peek and find another one here that you were doing. Let me go to this last one here. All right. So I see here that the mean daily rainfall in Los Angeles in December is 0.06 inches with a standard deviation of 0.03 inches. What is the probability that the total rainfall in Los Angeles for 36 randomly selected December days, possibly over several years, will exceed 2 inches? So again, this is going to be a greater than since it's an exceed one. Of course, carry the intermediate computations to 4 decimal places and report your result to at least 3 decimal places. So if I go back over here to my scratch paper, I know that my mean was 0.06 and that I had 36 selections there. So first thing I'm going to do is find my expected value by go ahead and multiplying the 0.06 times the 36, which is going to give me 2.16. I am then also going to do on my variance. So again, for my variance, I'm going to take my standard deviation and square it. My standard deviation is 0.03. I'm going to square that. So if I grab my calculator again, 0.03 0.03 squared. Did I get too many zeros in there? It looks like there's a lot of zeros. Let me type that in again. 0.03, there we go, squared is, that looks better, 0.009. So again, on here, this is my variance. I'm going to multiply that by the 36 attempts in order to find my variance for all 36 attempts. 0.0, I got one more zero's got to be in there. 0.0009. 1, 2, 3. 1, 2, 3. There we go. 0.3 zeros and a 9. I got the right value in there now. Multiply that by my 36. And I am going to get 0.0324. Again, I want the standard deviation of that number. So since this is my variance, I'm then going to do the square root of 0.0324. So square root of that number ends up being 0.18 for my standard deviation for all 36 attempts. Paper's hitting something else. Okay, so now that I've done that background calculations, now I can worry about my probability that I'm trying to exceed 2 inches. So when I go ahead and do my formula here, I want to do the probability that I exceed 2 inches so that I'm greater than. So this time my value is going to be 2 because I'm exceeding 2 inches, as opposed to this one with 11 cents. If I didn't lose any money, I would have $0. 0 means I broke even, right? I didn't go above 0, I didn't go less 0. So that's why I used a 0 there. Here we want to see if it exceeds 2 inches or not. So I'm going to use my 2 here, and then I'm going to subtract my 2.16, which was my expected value here. Notice up here we subtracted -11 because that was our expected value. Here we were losing money, so that's why that was subtracting a negative. And then we're going to put that over our 0.18, which was our standard deviation of our 36 attempts. Now again, because this one is a greater than, when we do the Alex calculator, we end up doing 1 minus that value. So I'm going to hop over here, grab my Alex calculator again. If it didn't kick me out, there we go. And I'm going to punch that in. 1 minus P of Z is less than or equal to, and I am going to have 2 minus 2.16. Highlight that. Divide that by 0.18 and hit equal. I get 0.812966, so forth and so on. We're going to round that off to 3 decimal places. So since I have 0.1829, 0.183 then is going to be my probability that I am going to exceed the 2 inches. Trying to find that problem again. That's not the right one. Of course, it probably closed it on me because I opened something else back up. And so just double checking here, yes, 0.813 is your answer. So hopefully that helps a little bit with these ones as to what they're doing there.